Okay, good morning. Welcome back. It seems like Monday morning this week has been a bit difficult for some people. Not you folks that are here, but just that there's about two-thirds maybe of the normal group that have been here the previous weeks. As a reminder, if you still are interested to give some feedback about week number 4, you can do that on the poll using the URL that's on the chalkboard up here, our normal polling place URL. And we'll get started maybe just by going through a few things about the feedback that is here for week number 4. And then I also was going to give just a very quick summary of the midterm feedback. The midterm feedback form is still open, so if you haven't filled that yet, please think about doing it. It's probably one of the more helpful ways to actually make a change or improve how we're doing things in the course. So there's still a few weeks where we can adjust how things are going based on the feedback that you provide us. But of course, you have to then provide the feedback for that to work. But yeah, I think the feedback that is here, questions and thoughts related to week number 4, at least one person's not really keen on the driver and navigator system. That feedback is actually something that also turned up in the midterm feedback, so that's not a complete surprise to us. And as you might imagine, everybody's different. We have people who really like that system, especially it seems to be helpful for people who have very little programming experience, but understandably, it's also something that might feel a bit frustrating if you are a bit more experienced, or if you just like to work on your own schedule and not have to deal with like arranging a time to meet with your partner. I think we understand that view. And that actually will be something that changes this week in our exercise, because this week and from this week onward, you have the option to work with your partner. We're not going to put as much pressure that you have to continue working with your partner. So we'll get to that when we get to the exercise. And then, yeah, the only other comment that's showing up here is that it seems clear, just need practice. So I presume that's just with the idea of making your own functions, that you basically just need to create functions and use them to see how this all works. And I think that that's not a big surprise there. When we get into using functions, this is one of the things where we sort of make a bit of a jump in terms of the concept behind what we're doing. But is there any other feedback about last week's lesson or exercise anyone would like to add at this point? I mean, even if you didn't type it in, is there anything else? Okay. So, yeah, well, then, as mentioned, I hope that you all saw this midterm feedback form. Well, I hope that, but I know that's not the case, or at least not everybody filled it in, because I can see the number of responses, and that's about half the number of people that are in the course. So this midterm feedback form is still open, I think, until maybe noon on Wednesday. So there's still an opportunity to give feedback if you haven't done it already. But the feedback form looks like this, and I was just going to very quickly summarize the feedback that's been collected so far, and just to kind of give you an idea of how things are going and maybe where we're going to go with using some of that feedback. So the first question, just about the pace of the lessons, whether it's too fast, too slow, or about right. On average, people said it's about right, but one thing that was noticed is that Kamyar and I have a little bit different pace when we're teaching, and I think for me, I've been teaching this course for many years now, so I've kind of gotten settled into a pace that seems to work based on feedback from years past. This is the first year that Kamyar is doing it, and so I think the pace will be something that at least now we're aware of, that there's a difference, and we'll try to adjust accordingly. Depending on your level of experience with programming, some people noted that it's too slow, some people noted that it's too fast, but we try to be, on average, about right. And I do note that one person said that it's helpful, like when we're typing things into the code cells, to be talking about what we're doing, so that like you don't have to be looking up at the screen and looking down at your screen all the time, but maybe you can listen and also be having to like just type things in just by listening. So anyway, the pace seems about right. Similarly, for the content of the lessons, you know, whether it's too simple, too difficult, or about right, again, on average, at this point, every year, there's a little bit of variation, but it's about right is the comment that I would say was most common here. Naturally, there are some people who have some programming experience who find it to be a bit easy, and some who don't, who find it to be perhaps a bit too difficult. But again, if you're finding things to be difficult, a really good thing to do is to go to the exercise help sessions on Thursday or Friday, or go to both if you feel like you really want extra help. Because sometimes even if you go and ask the same question to different course assistants, you may find one of them explains things in a way that makes more sense to you. So feel free to mix it up if you like. For the exercises, or sorry, that was for the lessons, rather, whether it's too difficult. And then exercises, I mean, the feedback basically for all three of these questions was about right on average. And yeah, the exercises this week and the next 2 weeks will be perhaps a little bit more challenging than the weeks before. So just a heads up that you may need to spend a little bit more time looking through the exercise for the coming weeks, because we're going to start doing a little bit more sophisticated kind of data analysis type things. Then about what elements of the course are most helpful for you. Off the top of my head, I don't remember exactly what was said here, but it kind of seemed quite variable. So everybody had a little bit of a different thing here. So some people liked working with a pair. Some people thought the recorded lesson videos were the most helpful thing. Some thought that the sort of network of people that were working together, so like just basically having your classmates that you could talk to was useful. Course webpage, the lecture sessions on Mondays, I mean, it's here, there's a little bit of everything. So I guess that's good. I didn't see Discord show up specifically here, so that makes me think that maybe it's not the most useful thing. But it also didn't really show up in something that's not helpful for the course. So I guess maybe people didn't necessarily think about Discord when answering that question. In terms of things that are least helpful, it seems like the most common response here was about the kind of course environment. So having this CSC notebooks and GitHub and Discord and all of these different platforms, it seemed like it was a little bit difficult for people to kind of just navigate that course environment. And we've tried to simplify things as much as we can. If you can believe it, it used to be more complicated even in the past. But there's a reason why we introduce all the things that we do, and it seems to take, you know, different people a different amount of time to kind of get the hold and like the picture of how all the different pieces fit together. So again, if you're having, you know, confusion about this, I would encourage you to ask us, or to ask in Discord, to ask the course assistants, and you know, we'll try to explain how the different things work. And if you want to know, like, why do we use GitHub? Like, why do we learn that, or whatever? I mean, you're not going to offend us by asking these kind of questions. If it seems like it's a total waste of time to use something, just ask us why, and we'll be more than happy to explain like the reason that we're introducing some of the different tools. I think that was the main thing, other than, yeah, some people did note the pair programming was something they thought was the least useful. Again, this varies from person to person, because some people thought that was the most useful thing as well. Then there's these different questions on the scale of 1 to 5, like how useful are the different things in the course. So just to give you I think this is based on roughly 32 responses, but the average scores here for the recorded lesson videos was about 4. For the exercise help sessions was about 4.3. For the pair programming, 3.3. Again, that one maybe you expect to be a little bit lower because some people like it and some don't. Then for Discord, 3.5, and for the discussion of the AI tools like ChatGPT, it was 3.6. So yeah, I mean, I think it seems like the things that are most useful are the lesson videos and the exercise help sessions, and some of this other stuff perhaps is useful to some, but maybe not everybody. Then there's two other questions here, and this is about suggestions you have to improve the course or any other general comments. The improvements for the course, there was a note about the pair programming being a bit clunky and also that we were a bit slow to get the pairs posted. I think we've already discussed this with Kamyar that we have a better strategy for next year to try to get the pairs paired up more efficiently and communicated to you sooner. And we'll be trying to see how that goes. Of course, we can't go back in time now to do much about that, but sorry if the pair programming thing was made even more difficult by the fact it took us a bit of time to get the pairs posted. And then there were several people who noted that they would like some extra information, like extra links about things in the course and places where they can go to find more material. I just want to note that on the course page, if you haven't seen it, down at the bottom, there is this resources section, and there is also within there this link for useful books and sites. If you haven't had a look, please do. There's a bunch of different things here. We are working on slowly working on a Python textbook, but it's openly available online, so you can go and check that out. You'll find material that looks a lot like this course in the first part of this Python book, but you'll also see things that relate to the AutoGIS 2 course in the second part of the book. So you can go and check that out. But there's also links here to other resources, like there's this computer science textbook, Python Programming Introduction to Computer Science. At least I find this to be one of the more clear and simple introductions to programming using Python, so you might want to have a look. I think you can find copies of this from the library here in Kumpula. Starting from today, we're going to learn this pandas library, so you can also check out this book, Python for Data Analysis, by Wes McKinney, who's the person who created pandas. If you click on the link for the book, it takes you to the open online version of the book, so you can go and basically see everything there explained by the author of pandas, so it's also quite useful resource. But beyond that, there's also these tutorials, there's Git and GitHub tutorials, so have a look at the resources that are here, and if we find anything else useful, we usually will update things and add them to the list of links here. But similarly, if you find a resource that's really good or something that you have found to help you with understanding Python, feel free to share it in Discord, and we can then also add that to the course page, because perhaps you guys find things that are I don't know, more relevant because you're looking at something that is, intended for new programmers, and you yourself are a new programmer, so perhaps it's easier for you to say whether something you find online is helpful. So then, otherwise about things that were possible improvements, again, there was some requests about having a live stream of the lectures. We've done that in the past, and what that tends to do is reduce the number of people who sit in the classroom quite significantly. So part of the reason why we do the live teaching and then post the lecture video later is that we'd like you to come here and sit in the room so we can see you and get a sense of whether people are confused or understanding things. So I think we're not likely to go to sort of live stream type like lectures on Zoom or something else. But otherwise, I mean, if there's other things that stand out in the feedback, we'll summarize this and share a link in Discord that has the kind of overall picture of what the feedback looks like. But I think that's the main observations so far. And if you have any feedback and have not yet filled in this midterm feedback form, please do that. Again, I think it's open till, it doesn't say on here, but I'm pretty sure it's open till Wednesday at noon. So you still have a couple days to fill in the feedback form. And again, that's useful feedback. Actually, there was one other thing I noted here that I just remembered, and that was about the assessment in the course. So if you go back to our grading section on the course page, you'll see that there's 60% from weekly exercises. I guess you guys are getting familiar with those already. 40% from the final course project. And so someone was asking about, like, can we have some information about what this final course project is sometime soon, because it's only a few more weeks left in the course. That's a very good idea. We have not posted the updated description of the final project to the course page yet. I think we'll introduce that maybe next week. But what I would say is, if you haven't noticed, down here on the bottom, there's this little version selector thing on the course page. And if you go back to the 2022 version of the course, you can find the final course or final project description here at the end of the list of things on the course page. And it includes a link to go to GitHub and see the description of the final exercise. So, of course, these dates will be incorrect, and it's possible we make some small changes to the final exercise compared to the years previous. Last year we didn't worry about like people using ChatGPT, for example, but this year I think we have to add something about that. But you can go through and you'll see what your task is, and this basically relates to exercises. Well, it kind of pulls a little bit of everything from the course into the final exercise, but this might not make complete sense about like making the plots and how to do that until after the week number 7 when we introduce data visualization. But you're going to end up making this kind of plot that has temperature anomalies. So essentially this is going to show how temperature deviates from an average for the different seasons of the year over, I think, something like 100 plus years of weather observations. And you're given, in this case, a station data from Sodankylä, from the weather station that's been running there since 1908. So we have, yeah, again, a bit more than 100 years of data. And there's some description here basically about what to do. You can go and have a look just to get a sense of where we're going. But as mentioned, next week we can have the updated version of the final exercise description and go through that in a little bit more detail. This is just if you want to get a sense of what's coming up. And the project is very closely related to the exercises in a sense, but we don't give you a template for the notebook in this case. You're kind of, I don't know if it's a fair analogy, but it's like taking the training wheels off the bike. So we've been giving you templates with like a very clear description of like do this, do this, do this in the exercise. And the final exercise, we're going to kind of take away the template part and just give you the list of tasks to do in a bit more open way. So that if you want to, you can change a little bit your approach to how you do things, and we won't be so structured in what you have to do compared to some of the exercises. Oops, now I've done it. Okay, I think that's maybe the summary of the midterm course feedback. And I guess at this point, perhaps it's good if I turn things over to Kamya, unless, are there any comments or questions about the midterm feedback? So as mentioned, once the feedback form closes, we'll put in the summary of the feedback to, it's a place that'll be on the course page, but it's not linked from the course page, just so that other people can't find it, but we'll put the link to the feedback in Discord, so you can go and check that out if you want to see what people have said. But yeah, if there's nothing else, then I think we will move on to today's lesson, and maybe I'll switch back to the current version of the webpage so we don't start teaching last year's material.
Okay, good morning everyone. So let's just get started with the actual content of the lecture today. So what we are going to talk about is the library called pandas. It's a very powerful library for working with data in Python. So what we have been covering so far during this course were some of the basic things you can do with Python, but for most of us who are not studying computer sciences or programming, what we want to actually do with Python, once we are good at it, is to actually process some data related to our work. So that's why this lecture and what we will be covering today and in the coming lectures are particularly important to what you will need later on. So yeah, we are going to talk about the library called pandas, which is a very powerful and feature-rich library for working with the tabular data in Python. So what are the learning goals? After this week's lesson, you should be able to read and explore tabular data in Python using this pandas library. You will be able to do some simple analysis using Panda, and you will be familiar with the structure of the data in Pandas and also some of the functionalities it brings for you. And you will also learn to write data to a CSV text file at the end. So as usual, we go to our notebook, Jupyter Lab notebook environment. If you haven't pulled the latest changes for the lessons yet, please do so right now. I have done it already for my session. So once you pull the latest changes, you should be able to see lesson 5 folder, L5, and the new notebooks there. Okay, so how many of you have pulled the latest changes successfully? Okay, good. So most of us are on the same page, so we can get it started slowly until others catch up. Okay, so Pandas is a modern, powerful, and feature-rich library that was developed by Wes McKinney. So you might be wondering already, what does it have to do with pandas and where does the name come from? And you even see a picture of a panda on the logo of the library. Well, it doesn't have anything to do with pandas actually. The name comes from, McKinney played with the words panel data. Panel data is a kind of tabular data. It's a bit longitude, and also you collect the same data over time. This is what panel data is. So he has played with the words panel data and also data analysis with Python and came up with the word pandas, which is also a bit playful. So that's where the name comes from. So yeah, so it has nothing to do with pandas. And of course, if you have some data set about pandas, you can analyze it using this library. But other than that, there's no connection. So yeah, so one of the good things about this library is that there are many good things about it. We will cover those today and the coming lectures. But one of the good things is that it is very common among professionals from different fields of science. So there is a lot of documentation online. So if you run into a problem, just Google your problem. Probably you will find many people talking about it. So there's a lot of documentation. There's a lot of resources available for Pandas library, which is great. Another great thing about this library is that it uses easy to use data structures. So there were other libraries that you can use for working with data. But one good thing about pandas is that the structure of data is very intuitive and very familiar for us. So it looks like a table. The data will appear like a table, very similar to what we are used to seeing in, for example, Excel spreadsheets. So you have different rows of your different rows in your data. You also have columns in your data. So it's quite intuitive and easy to work with. And also you will see this during this lecture, that you can address different columns by the name of the column, which is quite easy. And also the rows are indexed, a bit similar to what we have seen when we were working with lists in Python. So it makes it quite easy to work with. Yeah, so the Pandas library is a higher end library, meaning that it builds upon some of the older existing libraries. So it's not only combining some of the features of those, but also it's adding a lot of things. For example, it is building upon some libraries called like NumPy or SciPy. So it has many functionalities of those, plus a lot of improvements, but also it has some functionalities from the library matplotlib that we will be working with later on for visualization, for data visualization. So if you want to do some basic tasks, for example, if you want to make some simple visualization of your data, some of the functionalities of matplotlib, the library is here already, so you do not need to import it right away. Another good thing about pandas is that it supports different file formats for reading and writing. So most of the common file formats can be used in pandas without conversion, so you can just easily use them. For example, you can work with CSV files, JSON, HTML, different kinds of database files, and so on. So that makes it also quite useful. Okay, so now let's see what the pandas library is like. In order to understand it a bit better, it's maybe good to start with the data structures that we will be working with in pandas. So in pandas, we basically have two data structures. So one of them is this pandas data frame that we will be working with, and the other one is pandas series. So the difference between the two is that pandas data frames are two-dimensional, meaning that we have rows and columns, so they are basically tables. So that's one common data structure that we will be working with when we import our data to pandas to work with. The other data format that you will see is pandas series. So it is one-dimensional, meaning that you just have one row or one column in your data. So this is the main difference. So in these two examples, you can see that on the left you have this two-dimensional data frame where we have a number of rows and columns. The columns have names and each row has an index, which is similar to what we have seen when we were working with Python lists. And on the right side we have the Geo series. You see it's one-dimensional, so we have only one column. The other column you're seeing here is the index. So again, the rows are indexed here. So later on, for some of you who will be continuing in the second period with the Automating GIS Part 2, working more specifically with GIS, you will see that we will be working a lot with a library called GeoPandas, which builds on this library and adds like some geographical features to it. So there we will also see Geo data frame and Geo series. So this is a very for many beginners to pandas, this can be a bit confusing, especially when later you're using this, for example, for GIS, to confuse Geo series and Geo data frame, and then you run some kind of function and you might run into errors. So it is important to know the difference. So let's look a bit more closely at these two data structures. So you have the indices, and then you have the column names, and the data appears as a table, so you can see the values in your data. You can see the data type. In this case, we have numbers which are float, so they have decimals, and in GeoSeries you see also the name of the column or the name of the row of the data that you have. As David already mentioned, the original maker of this library has also published a book based on this called Python for Data Analysis. We have a link to that on the course's webpage, so you can go check that out. A third version of it is also released last year, so you can learn more there. Okay, so now we want to get started and do a bit of coding here. So input data, we are going to work, you can check it for the columns. We will see an example of that coming up later. Good question. We will get there soon. So to get started, we are going to use a data set that is a bit dated from 2016. So it has temperatures from Kumpula from 2016. So let's take a look at the data. The data is a text file coming in CSV format. So if you open the text file, it looks like this. So at the beginning of the file, we have some metadata. So there's information, metadata is data about data. So it tells you what you have in the data, where it comes from, who has prepared the data, what is the year, some basic information about the data. And then we have the data itself. On the first row of where the data begins, we have the name of the columns. So, and then on the following rows, we have the actual data. So we have a field where we have the date, where the temperature was collected. Then we have the temperature, and then we have the maximum and minimum temperatures for the day. And they are it's in CSV format. So I guess most of you might be already familiar with CSV. CSV is short for comma separated values. So you can see that the values on this data set are separated with a comma. So this is where the name CSV comes from. Of course, there are other versions CSV is by definition separated by comma, but there are other versions you can also see other examples of CSV files where the comma is not used. For example, it can be a semicolon or a tab between the values. Okay, so the first step, last week we saw how that if you have a library that is not the most, well, some of the functions that we use most often are already in Python when you launch your Python, but if you're using any functions, anything from other libraries, one of the first step you need to take in order to make the library available to you is importing the library. And for doing that, we write import pandas as PD. So we saw examples of this last week. So you just import, it's the name of the library, which in this case is pandas, as PD. So you may remember in some cases where the name of the library is a bit longer, it is common to pick a short name for it. For pandas, it's very common to use just PD. So later when you're using functions, you don't have to type pandas all the time. It's just enough to type PD. So if we run this now, the library should be available to us. So we want to load our data. So the data that I just showed you is in the same folder where we are. So the data is just saved there as a text file. So there is one library, there's one using the function pandas.read as underlined CSV, we can open our CSV file. So what we want to do now, we want to open our file and link it with a variable. So we store the data in a variable so we can use it later. So we just write data equals PD. So now we are referring to the pandas library. Remember that we picked the short name PD for it. Then dot read underscore CSV. And then what you need to pass to the function as your parameter is the name of your file. In this case, the file is in the same location where we are with our Python file. Otherwise, you needed to also provide the path to the file. In this case, it's there, so we can just type the name of the file. So I will just copy the name of the file from here. And that's it. So now the file is loaded, the data file, and it is saved in the variable data. So if you are working with other types of data files, for example, with Excel or Python Pickle, there are other functions that have similar functionality, but they allow you to import data from other formats. So this works with CSV, but if you are working, for example, with Excel file, then you can just use the function read underscore Excel to do basically the same thing. So now let's look at our data, see what it looks like. So you're familiar with the function print already. We have used it many times. So using print, you can have a look at your data and you can see the data is loaded. So one thing that I mentioned earlier when I was showing you the data file was that, well, in CSV most often the data values are separated with commas, but what if you have a data set in which another sign is used for separating the values, for example, semicolon. So in those cases, you should tell the function exactly what delimiter has been used in the data. So there is this parameter you can pass into your function called sep. So remember when we were talking about functions last week, one way of passing a variable into a function was by explicitly naming the name, mentioning the name of the parameter. So in this case, there is a parameter in this function called sep, which shows the separator in our data. And then you can explicitly mention what is the separator that is used in your data. In this case, because CSV by default is comma, we didn't need to do it, but it might be useful if you have other kinds of data. So notice that if you choose the wrong delimiter, for example, if we put semicolon here, and let's see what the data looks like, then you see that it doesn't recognize the columns in your data anymore because it was looking for a semicolon to identify the column. So be careful with that. Always check your data before working with it. So let's bring this back to comma and print our data. So we saw in our data file that we have around 30 rows of values in our data, but if we look at what Python printed for us here, we can see that we have around, well, we have 36 values, 36 rows. So we have more than what we should have, and the reason is that it's starting to count the rows, index the rows from the very beginning of the file where we had the metadata. So you don't want that to happen because that's not really part of your data. So that's one problem that we have in this file. One other thing that you might notice here is that you have a bunch of values that are not numbers. They are just NaN, which means not a number. And there can be several reasons for that. Most often it's just a missing value. You haven't had a value there. So Python shows it to you as not a number value. So it's a missing value. Or there could be also problems with the loading the data. So these are the problems we have. So let's fix one of the problems. So we are telling pandas to skip the first rows where we have the metadata. So we have 8 rows at the beginning of our file which have this information. So there are 7, you can see here. Also there is one line which is just blank with a space. So that's also one line we have to count. So we want to tell pandas that, okay, when you're loading my data, just skip the first rows because those are it's not part of my data. So let's try to import the data again and save it into the same variable we had earlier. So pd, short for pandas, dot read underscore CSV, and then we put the name of the file. I'm going to copy it from here again so that I don't have to type. Yeah, so we don't need to tell what separators to use because it's comma, so by default it will be okay. But what we are going to add here is the parameter skip rows, and we are giving the value 8, so it will skip the first 8 rows of data for us when it's loading the data set. So let's print our data again, and now it looks good. So you might one thing to mention here is that, like last time I was printing the data, I used print function, print data. Now I just put the name of the variable, so it gives us the same output. You will see your data. The only difference now is that now that we are working with in Jupyter Lab with a notebook, when you use the print function, it just shows you the kind of raw look of the data as like the Python version of it. But when you don't put the print function, it will show you the better looking version of the table. So it's essentially the same thing, just Jupyter Lab makes it look a bit nicer for you, so it's more formatted. But anyway, now you can see that the data is loaded correctly, so we don't see the metadata anymore, and we have around 30 rows of data, 29 rows of data, and that's correct. That's how it should be. Okay, so one way of, when you're working with your data, it's always important to, before you do whatever analysis, whatever work you want to perform on your data, it's good to have a look at the data first to see if everything is loaded correctly, is everything fine. For that, you saw one way of doing that is just to print your data, but this works now because you have like, I don't know, 30 rows of data, so it fits on your screen. But imagine if you're working with a large data set with thousands of rows of data. So if you print your table, it will be just a lot of rows. It will just fill up the screen and you don't make much sense of it. So very often to just make sure if the data is loaded correctly or if it looks fine, is enough to look at the first few rows of your data. And in order to do that, you can use data.head. So this will just give you the first 5 lines of your data, first 5 rows of your data. So if I do this, data.head, it just gives me the first 5. If you want to get more or less, you can just pass in explicitly a number here. So if I want to get like 8 first rows of the data, I just pass in 8, and it gives me the first 8 rows of the data. So there's a similar function if you want to look at the end of your file, end of your data file. You can get the tail. So it's data.tail. So this gives you the last 5 rows in your data. And again, similar to head, if you want to get a different number of rows, less or more, you can just explicitly mention the number and it will give you that. So data.tail, if I pass in 3, it will give me the last 3 rows in my data. Okay, so now we want to make sure, well, we have been talking about data structures in Python. We want to see what data, now that we have loaded the data into our variable called data, we want to see what data structure we are working with here. So we have seen this function before for getting the name, the type of variables. So the same thing works here, type, data, and we can see that we are working with a data frame here. So that's what it is. We have 2-dimensional data. We have rows and columns, so it is a data frame. Okay, so now we loaded all our data when we were opening the file using the read CSV function. What if you want to load only some of the columns of your data? How would you do that? You can achieve this using the use calls parameter, but maybe you can take a few seconds to see if you can figure this out yourself. So we want to make another data. Let's call it temp underscore data, and we only want to load the 2 columns year, moda, and temp, not all the columns we had in the original data. Okay. Did anyone manage to do this or has any idea to do it? Okay, we can slowly do it together. So just copied the earlier line of code so to minimize typing, but I changed the name of the variable. So this time I'm going to call it temp underscore data so it doesn't overwrite what I had earlier loaded into data. So we use the same function, pd.readCSV. The file is the same. We are skipping the rows. And what is different this time? We are using this parameter called useCols, like use columns, and you're passing in a list of the column names that we are going to load to our data. In this case, we are going to load 2 columns. One was this year moda, and the other one is temp. And then we are going to print the data. Let's get a head from the data to see how it looks like. Yeah, so we can see that you created a new variable, and in this new variable you loaded your data, but this time we only included 2 columns of our data. And this is how it looks like when we print the head of the data. Okay, so now we learn, yeah. Sorry? Yeah, it's a list. We have been working with lists. So if you're passing in a number of column names, so you put in a list. That's why you have that square bracket. Okay, so now that we learned how to load our data and save it into a variable, let's check out some of the properties of data frames. So some of the things we can do with this kind of data structure. So you remember that for getting the number of values in a list in Python, we use the function len, or which is short for length. So in order to check how many rows you have in your data in pandas, you can use the same function, so len. Then you put the name of your data. So it gives you 30. So it's an easy way of seeing how many rows you have in your data. If you want to get a quick overview of your data in terms of number of rows and columns you have in your data, then you can use the attribute data.shape. And this gives you an overview of the number of rows and columns you have in your data. So in our case, we have 30 rows and 4 columns in our data. Okay, let's get the name of the columns we have in our data. So in order to get the name of the columns you have in your data, you can use data.columns.values. So it gives you a NumPy array of with the name of the columns. So one other possibility is that you would just drop the values from end of this. So you would just get data.columns. It will give you the same output with the differences. This is just a different kind of object. This is a pandas index object, so it has a bit different functionalities that we will work with later on. So like the NumPy array is just read-only. You cannot make changes with using this. You can make changes. But essentially in this case, you get the same kind of output more or less. So you see the name of the columns in your data. Yeah, if you want to get more information about the index in your data, you can use the attribute data.index. So it tells you that your index starts from the value 0 up to the value 30, and the steps are 1. So this might seem obvious to you because that's like how it is in lists. But the thing in pandas is that indices by default are similar to lists. So it starts from 0 up to whatever number of rows you have. But we will see later during today's lesson that you can change the way the indices are created. So they can be any number, they can have different kinds of steps or increments, or they can be even like a string. It doesn't have to be even a number. That's why it's a useful attribute to have, to get this index attribute is useful to see how the indices are created. So in our case, we have starting from 0 up to 33, and the steps are 1. So we just have integers from 0 to 30. Okay, so back to the question we had earlier. If you want to see the data types for your columns, so you can just do data.dtypes, which is short for data types. So this gives you an overview of the columns you have in your data and what is the type of data you have in each of your columns. So in our case, we see that the year moda is integer, but the rest of the columns we have here are float with decimals. So let's try something quickly. How would you get the number of columns in your data? What do you need to write to get the number of columns in your data? Did anyone manage to get the number of columns? Okay, yeah, a few. Okay, that's good. So let's see how that works. It's quite simple. We use the same function that we have used before, the len function, but this time the variable we pass in is data.column. So we send that array of our column names to the function. It will count the number for us. Yeah, so in our case, it's returning 4, which is correct. We have 4 columns in our data. Okay, so now we want to see how we can select different columns. So you have you have imported your data as whole. So you have all the rows, you have all the columns that you originally had in your data. What if you want to make a selection of your data in which you have only 2 of the columns? So this is how you would do it. Let's name the new variable where we will store the new data selection. The original data we had was called data. Then we want to make a new selection of the data which has only 2 columns, year moda and temp. And now if we print selection, let's see what it looks like. Yeah, so as expected, now we have a new data set stored in the variable named selection, which has only 2 of the columns as we specified. So you might be wondering why you have 2 square brackets here. So we have the same thing here. We have multiple columns we want to include here. So we have to pass it in as a list. So I think if we have only 1, you do not have to put the other bracket, but let's try that. Yeah, so if you want to include only 1, you can just put it like that. But in our case, you want to include multiple columns, so we have to pass it in as a list to the function. Now if we want, let's check the type of the data we have here. So type selection. Again, we see that it's a data frame because we have more than one dimension. So it's a data frame. Let's get the shape of our data. So it has 30 rows and 2 columns. So basically when you make a selection of your original data, it's just kind of another copy of the data. It's a new data. So it's a new data frame. So all the properties and attributes, all the things we could do with the data frame, we can do it now with this selection. It's not different. So if you want to access just one column in our data, we can use data and then put the name of the column that we want to access. So yeah, so if you just put data is the name of the variable where you have stored your data, and then you pass in the name of the column you want to include, you can just get one single column from your data. So let's see what's the type of the data we have now. So for doing that, we again use the function type, and we pass in the data temp as the input. So now we can see that the data structure is series. It's not data frame anymore, and that's because we only have one column here. So that was the difference between the Panda series and Panda data frame. So it's one column, the data format is, the structure is series. So another way of accessing one column in pandas is just by, so this is the standard way of doing, and we recommend you to use this. So you just data, then you put square brackets and you pass in the name of your column there. But another way of doing this is just putting a dot and then the name of your column. So you get the same output. So it basically does the same thing. But why do we encourage you to use the first example? Well, first of all, because it's more versatile. So if you want more than one column, you can use the same syntax. In this case, this works for one column. The second reason is that if you have, for example, a space in the name of the column, you cannot use this anymore. You get an error. So if you use that other solution with the bracket, with the square bracket, you can use it in every situation with whatever column name. But with this one, if you have, for example, a space in the name of the column, you will have problem. You cannot use it. So it's best to go with the first solution. Okay, so as I said, in pandas, you can not only work with data, like you can import data, you can manipulate data, but also you can do some basic analysis. So one of the things you can do is to get some descriptive statistics from your data without importing any other library. So let's try a few of those. So let's get the mean values of one of the columns of our data, the temperatures. So I access the column and then I use mean. So this should give me the mean value of the column named temp. So again, as I said, you can access the column just putting dot temp, so it would give us the same output, but this is the way we advise you to use it. So yeah, so this gives us the mean value. If you do not specify the name of the column, you just use the name of the variable where you have stored your whole data. Let's see what the output will be like. So I just use data.mean. So what this does, it calculates the mean for all of the columns in your data because you haven't specified a single column name. So let's try another attribute, and that's data.describe. Okay. So if you use the attribute data describe, it gives you some descriptive statistics. So in this case, it's giving us the count, mean, the standard deviation, minimum, maximum, and the percentiles. You can of course like modify this a bit. For example, in the describe, you can check the documentations to learn how you can change this. But for example, in the describe, you can pass in parameters. For example, you can determine what percentiles you want to use. For example, if you put percentiles, so you can, for example, edit the percentiles you want to get. In this case, it will be 10%, 50%, and 90%. So there are a number of things you can change, but you can check those in the documentations. So in year moda, we have the date where the data was collected. So when we get this kind of descriptive statistics, it doesn't make sense to get it for year moda. So now take a few moments to see if you can print out the descriptive statistics again, but this time only for columns temp, max, and mean. So we don't get it for the year moda anymore. Okay, so we have already seen examples of how we can access columns in our data. So what we will be doing here is basically the same thing. So here we pass in the name of the columns that we want to be included when we are getting the descriptive statistics in our data. So in our case, we are using temp, max, and min. Again, note that it's a list. It's a list. That's why it's a list of name of columns. That's why we are passing in a square bracket, and you end up with this 2 square bracket. Then we have the attribute describe. And this time we don't pass in anything to just get the default. So now you can see that you can get the descriptive statistics only for the columns you specify: temp, max, and mean. Yeah, so as I mentioned earlier, so this is optional part of this lesson because we are going to get back to visualization and do it more properly later on during this course. But to just give you an overview, as I said earlier, like some of the functionalities of the library matplotlib, which is for visualizing data, is included in pandas. So for example, if you want to just create a quick visualization of your data, you can just use, you specify the columns you want to visualize in your chart and then dot plot. So it should give you a visualization of your data without importing any other library. But we will be working with visualizations more later on during this course. Yeah, so we just quickly go through this because usually when you work with data, very often in our case, we just get our data from some source. So you rarely need to type in your data yourself, but it's good to know that if you have your data, you need to type it in or bring it in from a list or some other source. You can also define data frames in different ways. So this is, for example, so just using a list, you can define a series in pandas, just using this syntax pd.series, and then you have a list of numbers. So what it does, it just creates a series. So it becomes a pandas series file, not file, pandas series of data structure. You can, I mentioned earlier that in pandas, you can also modify the indexing system you're using, so it doesn't have to be necessarily integers starting from 0. So in this case, you can redefine the same data series, but pandas series, but use different index like A, B, C, D. So you have that kind of flexibility with pandas. Let's try that. So you see the index values are now updated. It's just A, B, C, D. So you should remember that if you're trying to address a row in your data. Let's get the type. You see that, yeah, using that list, you defined data series, pandas series. You can do a similar thing if you want to create a data frame from several lists you have. For example, in this case, we have a list with the name of the stations, weather stations, and then we have separate lists for the latitudes and longitudes. And if you want to create just one data frame where we have names, latitude and longitude as a table, then we can just define, well, let's load the variables first. Then you can use this pd.dataframe, and then you just specify the name of the columns that you're going to use in your data frame. So it allows you to define a data frame, and this is the output. So, and if we check the output, the type of the output, it's a data frame. Again, it's more than one dimension, so it became a data frame. Yeah, sometimes it is useful to also define an empty data frame. For example, if you're doing certain kinds of calculations and you're going to store the values as you do your calculation in the data frame, it is useful to have an empty data frame. So you can just easily create an empty data frame. Let's name it df data frame, pd.dataframe, but without adding any data to it. So in earlier examples, we were adding the data from a list. In case we don't add anything, so it becomes just an empty data frame which we can later populate with our values. Yeah, so that was the first part of lecture. If you have any questions from this part, you can ask. If not, we can take a break.